question B here. So it is the sum of a fractions here, right? When n goes to infinity, for example, if n is equal to 1000, n squared, what is it? 1 million, right? When we compare these two guys, which one is bigger? Yeah, n squared is a lot bigger, right? In mathematics, we use this notation. It's a lot bigger. When n is equal to 1 million, 10 to the 6 here, what is n squared? Very good. Good job. It is 10 to the 12, and it is even bigger compared to n, right? That is why when we take the limit of the sequence 7n squared minus 2 divided by here 3n squared plus 5n plus 1. That is why we simply care about the highest degree of the numerator and the denominator. Because at infinity, the other guy simply becomes very tiny, right? Compared to the big brothers. That is why we should divide by the highest degree. In this case, and some notes, remark, if the order of the highest degree of the numerator and the highest degree of the denominator, they are the same, then we can simply divide it by the same things, right? In this case, it's n squared. The denominator, n squared plus 5n here. And if, now, suppose in the numerator, the degree of the numerator is smaller than the highest degree of the denominator. When n get big, right, it would be a very small numbers divided by a very big numbers. So it makes sense to say that it is converging to 0, right? But if the degree of the numerator, the order of this is higher than the numerator, when n becomes large, right, it will be a very big numbers divided by a smaller guys. It is going to infinity. So anyway, that is what we guess. And now when we do this, the fraction, this fraction on top here, we can separate it and it becomes 7n squared divided by n squared minus 2 over n squared. For those who don't remember these rules of fractions, this is how you deal with this. A fractions where it is the sum or of these guys, then we can separate them into these fractions. And now let us simplify it. 7n squared over n squared, what is it? 7. And this guy remains the same, right? So here, 3 plus 5 times 1 over n here, right? Plus 1 over n squared. When limit here, when n becomes very large, then this one becomes what? Very good, 7 over 3, right? And this, is it bigger or smaller than 1? Bigger, right? Very good. So what can we say about the series here? They say that if a series is convergent, then the sequence of this series, it means this guy, the limit should goes to 0. But it is not the case here, right? Therefore, the series 7n squared minus 2 divided by 3n squared plus 5n plus 1, and from 1 to infinity is divergent. And we should state which theorem we use. Here, in this case, it is by the test for divergence. Remember, the test for divergence, we can only apply it when the limit is larger than different from 0. Okay? If it converges to 0, we cannot say anything about this series. We should use different test. And remember, if a series is convergent and it converges by using one theorem, one test, it should also converge using different test. If somehow you apply a test, it say that it is convergent, and you use a different test to double check it, and it turned out to be divergent, it means there was some mistake in this computation. Double check it. If it is true for one thing, it should be true for another one. Okay? And that's it for this guy. Okay? Now, what's next? Want to try this one? C, okay? C here, look at that, as we have just discussed a few minutes ago. When we look at the highest order of the numerator and the denominator, in this case, what is the highest degree of the numerator? N, right? What is the highest degree of the denominator? N cubed, right? It means that these two sequences, I mean, we do it in our mind. I write it here just to show you. That is why, and this one is the same as 1 over n squared, right? Okay. That is why, okay, we think about the series. Let us the series 1 over n squared, and now the number c here, n will run from 2. That is why we also care about this when n is equal to 2 to infinity. That is how we think about this series. Now, we guess this series is a convergent or a divergent. Why? P series, and P in this case is 2, right? That is what we know, right, about this series. But our job is to prove this guy. So which test should we use here to say that this is convergent? We guess because they are somehow similar, right? So what should we do? Comparison, right? But in this case, we use the limit comparison, right? Let us call AN is this guy. And BN is this guy. Let us find in the limit comparison test, we have to find the limit when n goes to infinity, okay, of AN over BN here, right? Which is the limit when n goes to infinity of this series. So sorry. It's lazy and it takes more time. Okay, let's just write it. Limit when n goes to infinity, AN. So since we have done this many times, we don't have to, we can skip some basic step. Now we know that AN is this guy, we divide it by BN, it means that we multiply with the reciprocal of this guy, right? Okay. Now, when we do so, let us simplify it first. You don't have to simplify it. You can do it this way. I think it's faster. Okay. If n, this is the numerator, n times n squared, right? And the denominator is n cubed plus n squared plus 5n. It multiplies with 1, so it doesn't matter here. So what should we do now? It turned out the product here give us n cubed, right? Which is the same order of this guy. So what? Yeah, if we divide by n cubed, and here also divided by n cubed. I don't know. Okay, then we simplify it. The numerator becomes 1. The denominator again, it will be n cubed divided by n cubed, which is 1, plus n squared over n cubed, or we simplify it, will be 1 over n, right? Plus 5n divided by n cubed, which is 5 times 1 over n squared. Number 1 here we can ignore. So what is the limit of this guy? 1. This is a number, right? So this in our mind implies that somehow the series, if suppose in our head, just let's talk about the limit comparison test. AN, BN, if the limit here is about L, it means that we can write it means that somehow at infinity, AN will be L times BN, right? Or in other words, the sum of, if it is convergent, then the sum of the left-hand side should be approximately about L times the right-hand side series. That is what we think about the series. And therefore, if one series is convergent, it means the sum of that will be a number. Then the other series, the sum of that should be convergent as well. If one of them is going to infinity, the other guys will also go to infinity. That is why they are both convergent or divergent. In short, here from this limit, so we conclude that the series AN and the series BN are both convergent. Right? That's it. Since we know that the series Bn is convergent, then we have this conclusion. Now, is it clear why we choose this series Bn? That is the reason. Now, just let us make up an example to apply what we have just studied. Now, if someone just gives you this series, n cube, and here square root, let's say 7 root of n cube n square plus 10n plus 1, and they are even crazier. Add to outside of this radical sign, they add n squared, for example. What do we do? It looks very complicated, right? That is why let us do it in our head and see the biggest one of these two, the highest order. So what is the highest order of the numerator? N cubed, right? And what is the highest order of the denominator? Remember, say, at infinity, when n is very big, this guy becomes very small, right? Compared to n squared. Okay? That is why the highest degree of this radical sign should be around 7 root of n squared here, plus n squared. Then again, in these two guys, we compare which one is better, larger. That is why, okay, here, this guy, it is, let us write it differently. It is, what is it? 2 over 7, right? It will be 2 over 7 here, right? Okay. Plus n squared. Now I think if we put it this way, it's easier to observe, okay? So 2 over 7 is smaller than 1. N squared here is larger than 1. So the highest degree of this should be this guy, okay? That is why when we compare, we should compare with a series n cubed over n squared. And it is clear that n cubed over n squared is n, right? And n is a number is getting larger and larger. So we know that, okay, these two guys are both convergent or divergent. And clearly the right-hand side series here is divergent. Then we can claim that the left-hand side here is divergent. That is what we do in our head, but we need to prove it clearly, okay? But the same thing now, do you want us to do it together or just leave these problems behind? Okay, yeah, just leave it behind. And let us play with some other one. Which one? 10-8? Okay. Wow, looks scary, right? We haven't reviewed about this. And we don't remember any rules right now. There's no integration. When suppose we haven't done any integration after a few years. Now, when we look at this, what is the most difficulty things? What can we think about now? Which theorem and things? We know substitution, right? Integration by parts. That is the second thing. If you're dealing with root of x or something, x plus a number, then under the radical sign, it's very hard to deal with this guy. That is why we want to get rid of the radical sign, and we replace x by sine or cosine or tangent somehow to get rid of the radical sign, but it is not the case here. So what else should we remember about integration here? So which one can we use? Integration by parts, substitution, and trig function, right? Those are things we still remember. Now, what do you think? Integration by parts? Looks good, right? Because here we cannot do substitution. If we substitute u by x squared, doesn't help. Now let us try integration by part. Okay. So integration by parts, in order to do so, we should write two columns. The first column will be derivative, right? The second column will be antiderivative. It means that on the left, we take the derivative. In this case, which one should we do? This one here, if we take integral, it would be x cubed something, right? It becomes harder. Okay? So that is why we think about taking derivative of this. It is a polynomial. When we take derivative, it would be the degree of that would be lower and lower. That is why +1. Therefore, the other function, e to the negative 2x here, we would take antiderivative. What is derivative of x squared plus 1 here? Very good. So remember, we can do it multiple times. And derivative of 2x will be? And here, we should take the antiderivative of this guy. What do I miss here? Very good. Because e to the u derivative, it will be u prime e to the u, right? Now we can double check it by taking the derivative of this guy. clearly it gives us this. Okay, we take antiderivative one more time. What do we have here? Very good. And remember, we can do it multiple times. If you don't remember the integration by parts formula, you can always play with this. U and V prime. It would be the product rule. It would be U prime V plus U V prime. That is why when you take integral both sides, they should also be the same. And here, if we take integral of antiderivative, it will simply give you the function uv, right, on the boundary. Suppose it is from A to B, it's A to B, right? And here we have the two integral. That is why we think about this. Okay, anyway, now remember the rule is that multiply this guy, multiply this, and the last one will multiply this side. If you do it one more time, what is derivative of 2? 0, right? And here, what is antiderivative of this one more time? Multiply with -1/2, right? Therefore, if we do it this way, and remember, the sign will change alternatively. It always starts with positive here, then negative, then positive, and negative. And this rules tell us that the integral of from 0 to 1 of x squared plus 1 e to the -2x dx. You can apply integration by parts, step by steps, and double check the result at home, but this is the trick. So now, remember, it will be the product of this guy times this guy. Remember, there's a -1/2 here, e to the -2x. Then the sign of this is positive, right? Very nice. The sign of the next term will be negative of 2x here times 1/4 e to the -2x. And then the sign will change to positive. Here it will be 2 times -1/8 e to the -2x. And the last one, only the last one we would take integral. And the sign of that is from negative. The sign of that is negative. Only the last term, take integral from 0 to 1. And remember, we evaluate the value from the same limit here. 0 to 1, 0 to 1. The last one, it will be the product of 0 times -1/8 e to the -2x dx. So we see that when we do it one more step here, we can take advantage of the number 0 here. It will be simply 0, right? And finally, the integration by parts of this will be the result of these guy. So, because they are evaluated at the same boundaries, right? So before you can evaluate this, it is better if you can factor it. It will make the problems easier. Evaluate from 0 to 1. we did factor e to the negative 2x at the same times here because all of them has this term. So now you can deal with this guy at the same time. It's faster and a lot easier. You can avoid mistake. Okay, yeah, have a good semester and take care. I'm glad to meet you all.